Alright, so for part 2 of the test, you will be asked to do all of these different things. Just divide some polynomials. You'll have to find a polynomial function given the roots and write it in standard form. You'll have to find a polynomial function given the roots and another point, and with that one I'm not going to ask you to write it in standard form. You'll have to prove that things are an upper bound or a lower bound. You're going to have to find or list the possible roots for a polynomial function, and that's it. You don't have to find them for that particular one. You'll have some where you're going to have to find all of the roots of the polynomial function, both real ones and imaginary. And then you'll have to sketch the graph of a rational function and determine all of the different asymptotes and things that it has. So to start with, if we're going to divide a polynomial function, because this is 2x minus 1 and we have to do this the long way, and remember, when you're dividing, it is the first term into the first term, so that would be 2x squared, or 2. And when you divide that, or multiply this times that, you would get 4x to the third minus 2x squared. And then you're going to subtract, and this would be 8 minus a negative 2, so that is 10x squared minus 6x. Now again, we do first term into first term, and so that's going to be 5x. Multiplying 5x times the divisor then would get you 10x squared minus 5x. And again, we have to subtract, and a negative 6 minus a negative 5 would be a negative 1x. And then we bring down the 5. And then finally, 2x into a negative x would be a negative 1/2. And then when you multiply, you'd get a negative x plus a half. And subtracting again, 5 minus a half would be 4.5. And so then your remainder is 4.5. Now with this other division, because we're dividing by a binomial that has no coefficient for x other than 1, you can do this synthetically. And then on the inside of your synthetic division, you would have a 4, an 8, a negative 6, and a 5. And remember, if there's a missing term, you have to substitute a 0 in its place. And so now we add down, and that becomes 4, then a negative 12, negative 4, positive 12, 6, negative 18, negative 13. Remember, now that value is what f of negative 3 is equal to. It is also the remainder. And so then your answer would become 4x squared minus 4x plus 6, remainder negative 13. And there's your two division problems that you'll get similar to those. Now then we have to write this in standard form given these roots. Since 2 is a root, x minus 2 is a factor. X plus 3 would be, since a negative 3 is a root, and x plus 4. And now just writing it in standard form, you just have to multiply it all out. Multiplying those two together would get you x squared plus 7x plus 12, and then x minus 2. Now it doesn't matter which ones you multiply together first, that's completely up to you. And then doing this, that is what you get when you multiply the x times this trinomial. And when you multiply a negative 2, you will get that. And combining these, and then minus 24. Now if you get a root that is, say, 3i, then you would have x minus 3i and also x plus 3i, because the imaginaries have to occur in pairs with real coefficients. If it was something like 2 plus 3i, then you would have x minus 2 minus 3i and x minus 2 plus 3i. And then it would be wise of you to multiply those two together first, and then your imaginary parts should all go away, and you should just be left with something like this. The other one that you're going to be asked to do is something along these lines where you're given a coordinate on the graph and also some roots. So just like with the previous one, you're going to have x minus 1 as a factor, x plus 3, and x plus 4. We need to figure out a value for a to equal this, have this function be true. And so then you can take these things and substitute them in for x and y. And now solve this. That is 1, that is 5, that is 6. And so then you have 1 times 5 times 6 is 30. So 30a equals 14. Divide by 30. And a equals 7 over 15. And so then to write your answer, you would have f of x equals 7/15 times x minus 1 times x plus 3 times x plus 4. And for this particular question, I'm not going to have you write it in standard form. Had I, you would have had to multiply all of that out, get an answer, and then take that answer by 7/15 at the end. At least that would be the easiest way to do that. Then getting to proving something as an upper bound or a lower bound. Upper bounds only when you have a positive number on the outside. And so then we have, on the inside, we would have 1, negative 3, and there would be a 0 in there first. 0, negative 3, negative 5, and 2. And so now, going through this process, you get 1, 2, 2, 4, 1, 2, negative 3, and negative 6, and negative 4. This would not be an upper bound because not all of those are positive. And so now let's try 3. And when we go through this process, 1, 3, 3, 9, 6, 18, 13, 39, 41. All of these are positive, so yes, it is an upper bound, which means there's no root above that. Proving a lower bound, the value on the outside has to be a negative number. And in this case, we're trying a negative 1 first. And so when we go through this process, 1, negative 1, negative 1, 1, negative 2, 2, negative 3, 3, 5. That does not alternate between positives and negatives. So this is not a lower bound. Then trying a negative 2. We would have 1, negative 2, negative 2, 4, 1, negative 2, negative 7, 14, 16. They alternate, so therefore this one is an upper bound. Now remember, if any point of this up in here, if this would have been a 0, that can be positive or a negative. Or like over here, if this was a 0, that can be positive or negative, so this would still be an upper bound. that works down here as well. If this number right here would have been a 0, it's positive, negative. That can be both positive or negative since it's 0. So positive, negative, positive. It alternates. So that's an upper bound. And what that means is no root can be on that side of a negative 2. Then here we're just listing all possible rational roots. And that would be the factors of 10 over the factors of 2, which would be 1, 5, 2, 10 over 1 and 2. And so then you would just write plus and minus of 1, 2, 5, 10, because you put all of those over 1, and then you put all of those over 2. So you'd have 1 half. 2 halves is 1, which we already have written. 5 halves and 10 halves is 5. So those would be all the possible rational roots. And that would be it for that one. I wouldn't ask you to find any. Here's where you'd have to find them all. Now this first one, if you graph this, it's going to cross at 12 and it's going to go up, so therefore there are no rational roots. So in order to find them, we have to try to factor. And it's going to be x squared, and what are the factors of 12 that get you to 7? That would be 3 and 4. And if you set each part equal to 0, subtract 4, take the square root, you're going to get x equals plus and minus 2i. And here x is going to equal plus and minus the square root of 3i. 2 roots, 4 roots, that's how many we need. So we're done. With this next one down here, I'm going to have to do the synthetically. Factors, possible roots are going to be factors of 2 over the factors of 1, which would be plus and minus 1 and plus and minus 2. So then you would try on the outside or inside 1, 5, 6, and 2. And on the outside, try any of those. You start with 1 or negative 1. If you shouldn't start with any of the positive numbers because there are no sign changes, so there are no positive roots. You're just wasting your time if you don't remember that rule and you're trying to figure things out. If you switch this and substitute a negative x into it, that would become a negative x cubed plus 5x squared minus 6x plus 2. So that is 1 sign change, 2 sign changes, 3 sign changes. So we have 3 or 1 negative roots. And so we're going to try a negative 1 first. This would be 1, negative 1, 4, negative 4, 2, negative 2, and we found our root. Imagine that. So then you are left with x squared plus 4x plus 2. You cannot factor that because there are no factors of 2 that get you to 4. So then you have to turn to your quadratic formula. And that would be a negative 4 plus and minus the square root of 4 squared minus 4 times 1 times 2 all over 2 times 1. Simplifying this, that's 16. That's 8. 16 minus 8 is 8, and the square root of 8 is 2 times the square root of 2. So now we have a negative 4 plus and minus 2 square root of 2 all over 2. And since you can divide each of these values by 2, you then would have a negative 2 plus and minus the square root of 2. And so one root is a negative 1. The other 2 roots are a negative 2 plus and minus the square root of 2, which are both negative numbers. And so it is actually 3 negative roots. Finally, you have this where you have to graph and find everything. Remember, when you graph, you need to put this in parentheses and put that in parentheses and then divide them to find things with it. Horizontal asymptote first off, the one that runs this way. Well, in this particular case, there isn't one. And the reason there's not one is because that's 3 and that's 2, and the top cannot be bigger than the bottom for it to have a horizontal asymptote. But because the top is only one more, there is a slant asymptote, which you need to find by dividing x squared plus 3x plus 2 into x cubed plus 8x squared plus 6. And we probably should have left a spot in there, but that's okay. So what times x squared gets you x cubed? That would be x cubed plus 3x squared plus 2x. Subtract, that's nothing. That's going to be 5x squared minus 2x plus 6. Remember, you're subtracting, so it's 0 minus 2. Then what times x squared gets you 5x squared? That would be plus 5. 5x squared plus 15x plus 10. Draw our line and subtract again. That's 0. That's going to be a negative 17x minus 4. Now x squared doesn't go into a negative 17x, so this would be your remainder. We don't only need to worry about the quotient, so our slant asymptote is y equals x plus 5. So if we go up 5, and our slope is 1, then we have our slant asymptote running right through here. Vertical asymptote would be taking the denominator, setting it equal to 0 and solving it, factor it, x plus 2, x plus 1, so x equals negative 2 and negative 1. So that means we have a vertical asymptote at negative 2 and negative 1. Then the other things that you should be able to find would be the y-intercept, which the y-intercept is just going to be there, because if you substitute 0 in for all of those things, you get 6 over 2. So it's going to be y into 3 right there. And then the roots, or x-intercepts, would be just taking the numerator and setting that equal to 0 and solving it. In this case, it's really not anything that you can find easily. So put that in your calculator and graph it, and you will get an or an x-intercept of negative 8.091, which is right about there. And then put it in your calculator. You can even just put that in your calculator to find the y-intercept as well. Then this graph, I think, kind of goes like, it's going to go like this. There's a part in here, but it's way down there, like in the negative 80s or so. And then this part comes down and comes back up, and then we'll angle over to there, and then run along the slant asymptote. And then there will be a bonus question as well, similar to the one that you had for today, but not about the same show. And I think that is everything for this part of the test. Have a good evening.